Let us continue D block elements. In D block elements, we will see copper salts. We will see. In the copper salts, we will take a cuprous chloride. Cuprous chloride exists in the form of dimeric form. The monomeric form is CuCl. It will exist as a dimeric form Cu2Cl2. This cuprous chloride is insoluble in water. It is insoluble in cuprous chloride, cuprous bromide, cuprous iodide. That means cuprous halides, cuprous cyanide is insoluble in water. It is insoluble even in dilute hydrochloric acid. But with concentrated HCl, it dissolves due to formation of complex, we can say. It is soluble in concentrated HCl. Why? Because it is forming complex. It is forming complex. So and so complex is formed. So this cuprous chloride is insoluble in water, we can say, insoluble in dilute HCl, but soluble in concentrated HCl due to formation of like this complex. Then we will see copper sulfate we will take. To this we will add a KCN solution. What will happen? We are taking copper sulfate solution. To that solution we have added KCN. What is happening? We will see. The cupric ion with the cyanide gives a cupric cyanide, and that means this cupric ion with the cyanide becomes cuprous. Cyanide becomes cyanogen. Cyanide becomes a cyanogen C2N2. This C2N2 is called a cyanogen. This cuprous converting into cuprous cyanide, which is precipitate. Cuprous with the cyanide becomes cuprous cyanide, which is precipitate. This cuprous cyanide dissolves in excess of cyanide due to formation of complex, that is CuCN 4 times minus 3. So we are getting a complex here. The complex is a CuCN 4 times 3 minus. That complex we are getting. So cupric with the cyanide gives what? Cupric becomes cuprous. Cyanide becomes cyanogen. This cuprous becomes cuprous cyanide white precipitate, which dissolves in excess of cyanide to form complex CuCN 4 times 3 minus. Like this complex is possible, which is soluble. So copper sulfate with potassium cyanide, so on so reaction takes place. Okay. Next, CuCl2 is existing, or CuCl4 2 minus is existing, but CuI2 or CuI4 2 minus is not existing. We are saying that CuCl2 is existing, CuCl4 2 minus is existing, but CuI2 is not existing, CuI4 2 minus is not existing. Why is it so? Because cupric with I minus, what happens means cupric reduces to give cuprous, I minus oxidizes to give I2. This cuprous with I minus gives cuprous iodide white precipitate. Cuprous iodide white precipitate. So cupric iodide is not existing. Cupric iodide CuI2, CuI4 2 minus is not existing because I minus reduces cupric into cuprous. Cuprous precipitating as cuprous iodide. Next, we will take blue vitriol. Blue vitriol formula CuSO4.5H2. Blue vitriol formula CuSO4.5H2. This is heated. What happens? It is heated to 100 degrees Celsius. What happens means out of 5, 4 water molecules are leaving, Therefore, we are getting like this. Then it is further heated to 230 degrees Celsius. What happened means this water molecule also leaving. Therefore, we are getting anhydrous copper sulfate, which is white. This hydrated copper sulfate is pale blue. Hydrated copper sulfate is pale blue. On heating to 230 degrees Celsius, it becomes anhydrous copper sulfate, which is white. On further heating to 720 degrees Celsius, it decomposes to give what in the sense cupric oxide and sulfur trioxide. This on heating to 720 degrees Celsius, it is decomposing to give cupric oxide black and sulfur trioxide SO3. This on further heating, it decomposes to give sulfur dioxide and oxygen. So blue vitriol on heating becomes so and so. Sorry. Now, copper metal, when exposed to moist air, it becomes green layer over the surface. Copper metal on exposure to moist air, the surface gets green layer due to what? That we will see. Now copper, moist air contains water, carbon dioxide and oxygen. Now copper becomes what in the sense cupric hydroxide and cupric carbonate. This is called this hydroxide is there, therefore it is called a basic carbonate. This is called basic carbonate. Hydroxide is there, basic CO3 2 minus is there, therefore carbonate, basic carbonate. It is giving what color in the sense green color, therefore green layer we can say. So copper metal on exposure to moist air gets a green layer over the surface due to formation of this basic carbonate. That formula CuOH twice CuCO3 we can say. Next, copper does not dissolve in dilute HCl. Copper, silver, gold, mercury do not dissolve in dilute HCl. Now copper dissolves in con HCl. Here copper gives complex, the complex is H2CuCl4. So and so complex is formed. H2CuCl4. This complex is possible, which is soluble, and we are getting hydrogen gas. Copper dissolves in con HCl due to formation of complex and hydrogen gas. Copper undergoes oxidation and becomes Cu+2. H plus undergoes reduction and becomes hydrogen gas. Then we'll see anhydrous cupric chloride is solid, which is linear polymer. That structure we'll see. Anhydrous cupric chloride we are seeing. Structure of anhydrous cupric chloride solid we'll see. Anhydrous cupric chloride solid. This structure we'll see. Now CuCl2 will write like this. CuCl2 we are writing like this. Now what will happen here in the sense it is becoming polymer in the solid state. It is becoming polymer in the solid because of formation of bond like this. This Cl is making bond with copper, this Cl is making bond with copper. This Cl makes bond with copper like this. So like this bond is possible. Continuation like this. So because of this bond, like this bond, this anhydrous cupric chloride in the solid exists as linear polymer. Anhydrous cupric chloride in the solid exists as linear polymer. In the same way, anhydrous palladium chloride solid exists as linear polymer. This anhydrous palladium chloride solid is existing as a linear polymer we can say.